After finishing the axis and axis deviation, now we are jumping towards the hypertrophies. There are two words that is going to be used in this lecture. One is enlargements and other is hypertrophies. The enlargement word is going to be used for the atrias. We do not say atrial hypertrophy, we say atrial enlargements. And the word hypertrophy is going to be used for the ventricles. We use the word right and left ventricular hypertrophy. Okay. Before jumping to the pathology, first we need to revise some basic concepts. As we know that in one big box in an ECG, there are 5 small boxes horizontally and 5 small boxes vertically. One big box horizontally will be equal to 0.2 seconds and one small box will be equal to 0.04 seconds. But vertically we are not talking about the seconds. We measure the vertical length in millimeter or millivolt. The vertical length of a small box is equal to 1 millimeter or 0.1 millivolt. So the vertical length of 5 small boxes or one big box will be equal to 5 millimeter or 0.5 millivolt. Now look here, there are two leads that we are going to use for the atrial enlargement. One is lead number 2 and other is V1. The P wave is only an upward deflection and uniphasic wave in lead number 2, and in V1 the P wave is biphasic. One is upward deflection and other is downward deflection. Okay, and this is actually a normal physiological form of P wave in lead number 2 and V1. Okay, this is the normal form. Okay, now let's discuss the P wave in lead number 2 in a little bit detail, that what is the physiology of the P wave in the lead number 2. This is the P wave. Okay, it's a bit bigger and out of proportion, but it's for the understanding purposes. Okay, look at here, it is covering 1, 2, 2.5 small boxes vertically. Okay, so as we know that one small box is equal to 1 millimeter, so 1, 2 and 2.5 millimeter. 2.5 millimeter or less than that is the normal height of the P wave in lead number 2. This is one thing we need to remember. Okay, 2.5 millimeter is the normal height of the P wave in lead number 2, or you can say 0.25 millivolt height is the normal height of P wave in lead number 2. We are going to divide the P wave into 2 parts in lead number 2. The first part, this is the first part, okay, and this is the second part. The first part of the P wave represent the right atrium, or you can say the depolarization of the right atrium, and this part is going to represent the left atrium or the depolarization of the left atrium. Now let's see P wave in lead V1. Okay, we know that in lead V1 the P wave is biphasic, one upward deflection and one downward deflection. This is the baseline. Okay, there is one upward deflection and other is downward deflection. Remember that this one upward deflection will be equal to only one small box, and we know that one small box vertically is equal to 1 millimeter or 0.1 millivolt, and there will be one small box downward deflection, and one small box downward deflection will also be equal to 1 millimeter. There is one more thing. This part of the biphasic P wave in lead number V1 shows the depolarization of the right atrium, okay, and the downward deflection will shows the depolarization of the left atrium. Now, after understanding this core concept, it is much easier to jump into the pathology. You guys is going to understand it better, okay? There is one more point remaining to discuss before jumping to the pathologies, and that is the horizontal length of the P wave. The horizontal length of the P wave, we have discussed it already there in the normal physiology of the ECG, that it will be equal to 2.5 small boxes, okay, as it is equal to 2.5 small boxes vertically. And we also know that this first part of the P wave is going to show the depolarization of the right atrium. Remember that whenever a right atrial hypertrophy occurs, this first part of the P wave is going to be increased more than the normal, which will be more than 2.5 mm or more than 2.5 small boxes. Like for example, it will be like this. It means that atrium has been enlarged. That's why an enlarged action potential is required to depolarize it, and we call it right atrial hypertrophy, okay? So again, in right atrial hypertrophy, this first part of the P wave is going to be enlarged vertically. See, vertically more than 2.5 small boxes. We call it right atrial hypertrophy. Now come to the left atrial hypertrophy in lead number 2. We know that the left atrial hypertrophy is going to affect this latter part of the P wave. And remember this point, that it is not going to affect this P wave vertically. The latter part of the P wave is going to be affected horizontally in the left atrial hypertrophy, as it given as under. See, vertically it still equals to 2.5 small boxes. 1, 2, 2.5. See, the height is equal to 2.5 small boxes. The length is more than 2.5 small boxes as compared to the upper one. See, 1, 2, 2.5 small boxes is the horizontal length of the P wave in the normal P wave, but here it has been increased. 1, 2, 3. It's almost like 4 small boxes horizontally. So if the horizontal length of the P wave increase more than the normal in lead number 2, we call it left atrial hypertrophy. Now there are specific names given to these waveform. If vertically the P wave increases, we call it P pulmonale, and P pulmonale is nothing but it's a right atrial hypertrophy. And this, look at this P wave, it is looking like an M, okay? So if the P wave is like an M pattern in lead number 2, we call it P mitral, and P mitral is nothing but it represents the left atrial hypertrophy. Now the waveform of lead V1, we know that the upward deflection of the V1 P wave is showing the right atrium, and this is showing the left atrium. If this is enlarged as compared to the downward deflection, we know that this is a right atrial hypertrophy, because this represents the right atrium. And if the upward deflection is smaller and the downward is greater deflection, then we say that this is left atrial hypertrophy. I'm sorry, I'm saying right and left atrial enlargement. It should not be hypertrophy, it is enlargement. Right and left atrial enlargements. Now look at this chart. This is the summary of the atrial enlargements. Okay, we know that the height of the one large box will be equal to 0.5 millivolt or 5 mm. Okay, for atrial enlargement we see lead 2 and V1. Normal waveform of lead number 2 and V1 is, we know that there will be only upward deflection in lead number 2 and upward and downward deflection in lead number V1. Okay, the normal height of P wave in lead number 2 is equal to or less than 2.5 millimeter vertically, and in the V1 it will be equal to 1 mm, 1 millimeter, one small box. Okay, upward and downward both, 1 millimeter upward and 1 millimeter downward. Now see the right atrial enlargement. In lead number 2, if the P wave is greater than 2.5 mm, then we call it right atrial enlargement. And at the same time, we know that in lead number V1, the upward deflection also shows the right atrial depolarization, and it is normally equal to 1 mm. If this deflection is greater than 1 mm, then we call it right atrial hypertrophy. We call this wave as the P pulmonale. So overall about the right atrial hypertrophy, if in lead number 2 there is tall P wave, or in lead number 1 the upward deflection is greater than the downward deflection, we call it right atrial enlargement. Come to the left atrial enlargement. In lead number 2, if the P wave is greater than 0.1 second, 0.1 second mean that it will be greater than 2.5 small boxes. Okay, and we have discussed just a few seconds ago that the left atrial enlargement will be horizontal, not vertical. So in lead number 2, if the P wave is greater than 2.5 small boxes horizontally and it is an M pattern, we call it right atrial hypertrophy, and this M pattern waveform is known as P mitral. And in lead number 2, the downward deflection will be greater than the 1 millimeter, and we call it altogether left atrial enlargement. Let's jump towards the ventricular hypertrophy. We were using lead number 2 and V1 for atrial enlargements. Here we are going to use lead number V1 and V6 for ventricular hypertrophies. The normal ECG waveform of V1 and V6 are here. V1 predominant deflection will be downward, and in the V6 the predominant deflection will be upward, as it was discussed earlier in normal ECG waveform. It's because V1 is lying completely opposite to V6, so the waveform that is formed by V6 is completely opposite to V1. Okay, here we go. The right ventricular hypertrophy. If the waveform in V1 and V6 are completely becomes the opposite of the normal ECG waveform, it is known as a right ventricular hypertrophy. And how is that? The normal ECG waveform would be predominantly downward deflection in V1 and predominantly upward deflection in V6, but it is completely opposite. Okay, or let's consider there is a person standing here. It's a very good and simple example. That's how you can diagnose the right and left ventricular hypertrophy. Let's consider his right arm is showing V1 and his left is showing V6. If the right arm goes up and the left goes down, it means if the V1 is upward deflected and the V6 is downward deflected, this is right ventricular hypertrophy. Okay, the left ventricular hypertrophy. Look at lead number V1 and V6. See, the deflection is the same as in the normal ECG waveform. see, in the V1 the predominant deflection is downward, and in the V2 the predominant deflection is upward. But here is another problem. The downward deflection QRS complex that is produced will be very deep as compared to the normal one. For example, in the V1 the downward deflection will be greater than 26 mm, mean more than 26 small boxes, and in the V6 the upward deflection will be greater than 35 mm, means more than 35 small boxes. But when we talk about the normal waveform in a person who is not having left ventricular hypertrophy, his or her V1 should be less than 26 mm, and her or his V6 deflection, which is upward, should be less than 35 mm, okay, or 35 small boxes. Now it's time to show you the real ECG of right and left atrial enlargements and right and left ventricular hypertrophies. Let's go for it. So this is the ECG of a right atrial enlargement, where I cannot appreciate tall P wave, which is P pulmonale, in lead number 2, because this ECG has other multiple issues as well. See, I cannot appreciate the P wave is taller. But if you come to the lead V1, see, this is V1, and come to the P wave, this is QRS complex, and before that you have this P wave. The P wave upward deflection is greater than the downward deflection. This is the downward deflection and this is the upward deflection. See, so this is right atrial hypertrophy. P pulmonale cannot be appreciated very well in lead number 2. See, but in V1 the upward deflection is greater than the downward deflection, and that's how we diagnose it as right atrial enlargement. Look at this, guys. See, here you can appreciate a P mitral, which is left atrial enlargement, very nicely. Let me maximize it for you guys. This is lead number 2, and look at this. It is like M pattern. This is the P wave and it looks like M. This is P mitral. Look at another one. This is P mitral. It was lead number 2, and now let's come towards lead number V1. Look at this. This is lead number V1, and look at here. This is the P wave, and the upward deflection is smaller and the downward deflection is greater. So this is left atrial enlargement. In this ECG, I'm going to show you the right ventricular hypertrophy. We have studied that in V1, the QRS complex, or you can say the predominant deflection of the waves, should be downward normally. But look at here, we have drawn that man. The right, you can say the V1 is upward deflection, and in the V6 it's downward deflected, which is exactly the opposite of the normal, where the V1 should be downward deflected and the V6 should be upward deflected. But here we see the opposite scenario, which is V1 is upward deflected and V6 is downward deflected. But there is one more point where the QRS complexes are actually overlapping the QRS complexes below them, okay, and it means that the right atrium has been enlarged, or you can say hypertrophied, that it now needs larger amount of action potential to depolarize them. So these are the 2 points that is a diagnostic for the right ventricular hypertrophy. One is V1 is upward deflected and V6 is downward deflected, which is opposite to the normal, and the other one is QRS complexes are larger than the normal one. this is the last one where we're going to study the left ventricular hypertrophy. See, the reflection in V1 is predominantly downward, and in the V6 it is upward, which looks normal. Means the direction of the deflection is normal in the V1 and V6. But look at this. It's very deeper than the normal. This QRS complex, which is downward deflection, is very deeper than the normal, and it's even like overlapping the QRS complex of V2. See, and look at V6. In the V6 it's not coming very very likable for ventricular hypertrophy, but in the V5 it is again overlapping the QRS complexes of the V4. So the direction is normal in V1 and V6 and V5, but the length, or you can say the height of the QRS complexes are greater than the normal. For example, in the V1 it should be greater than 26 mm, and in the V5 V6 it will be greater than 35 mm, and that's how you diagnose left ventricular hypertrophy. Or in other words, you can say that these QRS complexes are greater than in height than normal, just because the myocardium of the left ventricle are enlarged. Now the enlarged ventricle needs big amount of action potential to depolarize it. That's why a big QRS complexes are made in V1, V2, V3, V4, V5 and V6. Okay, so that's it for the hypertrophies and enlargements. After this we are jumping towards the myocardial infarctions.